Okay, this video goes with 5.3 practice trig functions on the unit circle. At the top we have a reference triangle which shows that if you have a unit circle, the endpoint of the terminal side has an xy coordinate on the circle, and x goes with cosine of the angle and y goes with sine of the angle in standard position. When we talk about the quadrantal angles on the unit circle, at 0 or 360 degrees, the endpoint has a coordinate of 1, 0. X is 1, y is 0, which means that cosine of 0 or 360 is 1, sine of 0 or 360 is going to be 0. When we talk about the 90 degree angles, the endpoints are 0, negative 1, so cosine of 90 is 0, sine of 90 is negative 1. 180 degrees, endpoint negative 1, 0, so cosine of 180 is negative 1, sine of 180 is 0. 270 degrees has 0, negative 1 for the coordinates, so that means that sine of 270 is negative 1 and cosine of 270 is 0. Again, cosine goes with the x coordinate, sine goes with the y coordinate. Notice that 270 is also the same thing as a negative 90, so we could say that cosine of negative 90 is 0, sine of negative 90 is negative 1. Negative 90 is the same thing as 270. In terms of radian measures, 0 in 360, 360 is the same as 2 pi, 90 is pi over 2, 180 is pi, and 270 is 3 pi over 2. We did some work a while ago with the special triangles, and so this page has a chart that I got from someplace on the web as kind of a reference, and you should be at this point able to, whenever you need to, sketch a 45-45-90 triangle or a 30-60-90 triangle and label the ratios of the sides. With the 45-45-90, it's 1, 1 radical 2. 30-60-90 is 1 radical 3, 2. So the sine of 30 is 1/2. Cosine of 30 is adjacent over hypotenuse, which gives root 3 over 2. Sine of 45 is 1 over radical 2, which is radical 2 over 2. Cosine is the same thing, radical 2 over 2. Tangent would be 1, etc. So we had practiced a while ago on generating these charts and these values. These are going to be really useful to sketch as we deal with the special angles. Remember that 45 degrees is the same as pi over 4, 60 degrees is the same as pi over 3, and 30 degrees is the same as pi over 6 in radians. For number 4, we need to find the 6 ratios that go with 45 degrees, which is the same as pi over 4. So this angle in standard positions in the first quadrant, and so we have sine of 45 or sine of pi over 4, cosine 45 or pi over 4, tangent pi over 4, and I usually just set up the ratios first, or the trig ratios first before I actually put the numbers in from the triangles. With secant we have cosecant is sine inverted, cosine inverted is secant, and tangent inverted is cotangent. So basically we're going to take sine, cosine, and tangent and flip them upside down to get the cosecant, secant, and cotangent. Tangent of 45 is opposite over adjacent, 1 over 1, and then cotangent is also going to be 1. Cosine is 1 over radical 2, which is radical 2 over 2. Sine is the same thing. When we flip those over and do a little bit of work, cosecant is radical 2 and secant is radical 2. Since the 45 degree angles in the first quadrant, these all remain positive. Now with 120 degree angle, 120 degree angle is 30 degrees into the second quadrant. 90 plus 30 makes 120. which means that the reference angle, which is the angle needed to get down to the x-axis, is another 60 degrees. So we're going to use 60 degrees for our reference angle, and it's in quadrant 2. Now in quadrant 2, sine is positive and tangent and cosine are going to be negative, so we have to remember that. At the end we attach those signs. We sketch a 30, 60, 90 triangle, and we're going to basically use the 60 degree ratios for this one as a reference angle. So we have sine of 60, cosine of 60, and tangent of 60. Now these are equivalent to, in the second quadrant, once we attach the signs, it's going to be like sine of 120, cosine of 120, tangent of 120. And then we do the cofunctions, cosecant 120, secant 120, cotangent 120. Now what I put was basically like the pi over 3, but we'd really be doing 120 there. So if we're talking about 60 as our reference angle, sine is going to be root 3 over 2, opposite over hypotenuse. Cosine is going to be 1 over 2, and tangent is going to be root 3 over 1, or just root 3. So when we do the cofunctions, root 3 over 2, we flip it over, we get 2 over root 3, have to rationalize it, we get 2 root 3 over 3. 1/2 inverted is 2, so cosine goes to secant being 2, and tangent is 1 over root 3. Cotangent's 1 over root 3, which simplifies to root 3 over 3. With this next set of problems, we are given the coordinates of the endpoint. So number 6 is going to be in the second quadrant. Oh, okay, one thing I forgot is with the 120 degree angle is in the second quadrant, so sine is positive, cosine and tangent are negative. We need to stick negative signs on cosine and secant and tangent and cotangent because of it being in the second quadrant. So we have an endpoint at -2, 5, which means that the hypotenuse is going to be square root of 2 squared plus 5 squared, which is root 29. So the length of the radius there is going to be root 29. Oh, that's a 1. So the radius is going to be root 26. And we set up sine, cosine, and tangent of that angle. So sine is going to be opposite over hypotenuse, which is 5 over root 26, which has to be rationalized. Cosine is going to be -1 over root 26, which has to be rationalized. And tangent is going to be 5 over -1, or just -5. And then we do the same thing for the cofunctions. Basically, sine is 5 over root 26, so cosecant is going to be root 26 over 5. Cosine is -1 over root 26, so secant is going to be negative root 26. And tangent is 5 over -1, which is -5, so cotangent is going to be -1 over 5. So we fill those in. So we're doing the Pythagorean theorem. This happens to be in the second quadrant, so if we check the signs in the second quadrant, cosine and tangent should be negative, and we can see that cosine and tangent values and the cofunctions are negative, and sine should be positive in the second, and we see that sine is positive in the second. For number 6, we have an endpoint at 7, 0. So we pretend it makes a triangle. The opposite side of this triangle is going to have a height of 0. The adjacent side is going to be 7, and the hypotenuse is also going to be 7. So Sine is going to be opposite over hypotenuse. 0 over 7 is going to be 0, which means that cosecant is going to be 1 over 0, or undefined. Cosine is adjacent over hypotenuse, which is 7 over 7, which gives a value of 1. And then secant is also going to be 1. And tangent is opposite over adjacent, which is 0 over 7, or 0. But then cotangent would be 7 over 0, which would be undefined. So we fill those in. The next one, we have -3, -4. So -3, -4 is in the third quadrant. That goes with T with all-star trig class. That means tangent's going to be positive, sine and cosine should end up negative. And this actually sets up a 3, 4, 5 Pythagorean triple. So the hypotenuse length is going to be a 5 there. And pretty much it's the same thing that we were doing before. Sine is going to be -4 over 5. Cosine is going to be -3 over 5. Tangent is going to be -4 over -3, which comes out to be 4/3. And then when we do the cofunctions, we basically flip those fractions upside down. So we set up the ratios. And since this is in the third quadrant, we have all-star trig class. T is in the third quadrant. So we're going to see that tangent ends up positive and sine and cosine end up negative. Sine ends up -4 over 5, which means that cosecant is -5 over 4. Cosine is -3 over 5, which means that secant is -5 over 3. Tangent is -4 over -3, which makes the positive 4/3. And then cotangent is going to be 3/4. And so that's all that we have for this practice. Again, you should review the videos to be sure that you're okay with some of these basic ideas, and you may need to go back and look at section 5.1 notes and maybe review some of those videos also.